Throughout the world, drilled shafts are used as deep foundations to support large axial loads from high-rise buildings, bridges, and other up-reaching structures. Drilled shafts are commonly constructed by employing rotary drilling equipment to drill a cylindrical hole. This hole may remain open in soils with cohesion or rock. When caving soils are encountered, the hole may be kept open by using drilling slurry or casings. The slurry method can consist of circulated water suspensions, or mineral and polymer slurries may be added. A casing can be placed in the hole by an impact or vibratory hammer to support the excavation. If necessary, the steel casings are joined by welding and separated when the temporary casing is removed after concreting of the shaft. In the early 1960s, drilling contractors in Europe were challenged by a high concentration of structures and regulatory requirements. This led to the development of the first generation of pneumatically driven casing oscillators. This new technique proved to be a low vibration, impact-free casing installation method, which could prevent damages. With the success of this technique, more powerful hydraulic casing oscillators and later rotators were developed. Today in Europe, drilled shafts are predominantly constructed in a full-depth, cased way using oscillators and rotators. In North America, slurry-supported boreholes are more common due to the physical limitation of the equipment presently being manufactured in the United States. The oscillator rotator casing method utilizes a circular collar to clamp onto the drill casing. The collar rotates 20 degrees in alternating directions. The casing is pulled and twisted into the ground by hydraulic jacks with torques of up to 6 million foot-pounds. Drill casing is available in lengths of up to 8 meters. During the drilling, sections of casing are joined by tightly fitted collars with inset conical casing screws. The wall thickness of heavy-duty drill casing ranges between 40 and 60 millimeters. In the 1980s, a new generation of hydraulic rotator machines was developed with a maximum torque of 6 million foot-pounds combined with a full 360-degree rotation capacity. This machine utilizes a cutting shoe with teeth optimized for cutting in one direction only. As a result, this system enables the casing to penetrate difficult soils, boulders, and rock sockets. These one-directional rotators are about 30% faster than traditional casing oscillators. Rotary advanced casing is a proven installation method that provides a wide variety of advantages. This method makes a stronger shaft. The risk of defects within the shaft is minimized. Tolerance and exactness of the shaft is more accurate. When horizontal loads have to be transferred, the production of a sound drilled shaft is essential. This installation method eliminates the use of slurry and decreases concrete overbreak. Rotary advanced casings are better able to penetrate into the soil under any geological and hydrogeological condition. The casings are able to pass through and contain hazardous or contaminated soils. With hydraulic drill rigs, the installation of casings is improved by joining segments during the drilling. Oscillators and rotators also reduce the risk of leaving temporary casing in the ground. Casing oscillators and rotators are being used all over the world for the successful installation of full-depth casings. This low-vibration, impact-free casing method reduces potential delays and cost overruns, while a safe and economic foundation element is created. The following segments are recent jobs Malcolm Drilling Company completed using the full cased installation method with rotators and oscillating equipment. The Leffer oscillator is a new piece of equipment introduced to the United States from Germany. This awesome machine with 5,250,000 foot-pounds of torque oscillates the casing into the ground. These huge rams are what helps power the machine, twisting and pushing the casing easily through a variety of soil conditions. The grabs clam out the dirt and muck and dump it onto the ground. During this time, the oscillator continues oscillating. The temporary casing is placed in 8-meter sections. The initial section of casing has cutting teeth to facilitate the coring action. The use of the oscillator is a low-vibration, impact-free casing installation method. Due to the close proximity to the freeway and traffic, this method proved to be efficient and greatly reduced the risk of potential damages. The rebar cage at 96 feet in length was lifted on the other side of the access road due to the difficulty in access and the length of the cage. The cage was carefully placed into the hole. Malcolm Drilling Company uses its own pump truck to pump concrete to the hole over a great distance due to the difficulty in reaching the hole. The lever oscillator removes the casing sections as concrete is poured. The extracting rams and torque of this fantastic machine enable it to pull out the temporary casing quickly and easily. Each 8-meter section was removed in 8 to 13 minutes. Bolts that hold the casing sections are removed using an impact wrench. One section is successfully lifted off and the pump truck resumes pumping concrete. The Redondo Grade Separation Project is the construction of a bridge that will provide higher speed service for both passenger and cargo trains over Washington Boulevard, the Los Angeles River, and Soto Street near downtown Los Angeles. The foundations for this bridge consist of cast and drilled hole piles that support the 35 bents and 2 abutments. The Leffer 2.5-meter hydraulic casing oscillator was used to drill holes 6.5 feet to 8 feet in diameter and up to 125 feet deep. The oscillator operates by rotating 20 degrees in alternating directions while using powerful hydraulic jacks. This awesome machine continuously oscillates, twisting and pushing the casing steadily down into the ground. The drill crew worked in close proximity to live trains running as close as 25 feet away from the centers of the hole. At the same time the casing is twisted into the ground with the oscillator, the Liebherr 873 crane excavates the soil from inside the casing using a clamshell digging bucket. Poorly graded sand with some clay layers were encountered during excavation. This type of soil is very difficult and dangerous to drill with a conventional auger due to the possibility of caving. The use of the oscillator proved to be the safest and most efficient way to drill these piles as the potential for caving soil and a tight workspace were encountered. The Terminal 18 project is the next stage in the redevelopment of the Port of Seattle's master plan. Malcolm Drilling Company worked extensively with the general contractor on drilled shafts for the main bridge structure that would provide entrance and exits for all truck traffic in and out of the port. Railroad traffic, hidden obstructions with buried debris, and the existence of new and existing utilities were a few of the complications encountered on this project. The use of the rotator with the fully cased installation method greatly reduced these concerns and risks. The massive rotator, weighing 260,000 pounds, was positioned over each hole on a specially made steel platform. The rotator measures approximately 18.5 feet in width, 22 feet in length, and 13 feet in height. An initial section of casing with cutting teeth to facilitate the coring action was first positioned over the hole. Temporary sections of casing were continuously twisted and pulled steadily down into the ground. The rotator rotates the casing into the ground with 5,340,000 foot-pounds of torque, easily coring and handling many types of soil conditions, from hard rock to bay muds. Additional sections of casing, 20 feet in length and weighing over 38,000 pounds, were added to drill shafts up to 125 feet in depth. The rotator has the capability to drill holes up to 10 feet in diameter and over 200 feet in depth. The bridge support was designed with 2 drilled shaft supported abutments, with 4 6.5-foot drilled shafts at each abutment and 7 piers with 2 10-foot shafts at each pier. The geotechnical makeup of the site for the installation of the shafts was mainly loose to medium dense dark gray to black sand. The grabs clam out the dirt and muck, while the rotator continues to rotate, forcefully twisting the casing into the ground. The rebar cage was constructed nearby and set in the hole by the large crane. The average concrete placed per shaft was 278 cubic yards, with the largest pour at 320 cubic yards. As the concrete is poured, the rotator easily extracts each section of casing. This incredibly powerful machine has a lifting force of 1,110,000 foot-pounds. Bolts that hold the casing sections are removed using an impact wrench. One section is successfully lifted off and the pump truck resumes pumping concrete. After concrete is poured and casing extracted, a collar was placed at the top of the hole and connected to the rebar cage. This successful project was observed by many of the surrounding engineering firms and governmental agencies from as far away as Canada and California. In the middle of the raging waters of the Truckee River in Reno, Nevada, Malcolm Drilling Company is drilling shafts using the fully cased method through contaminated soil. The XL 1500, a state-of-the-art rotator, is drilling shafts 5 feet in diameter and up to 60 feet in depth through cobbles, boulders, and caving sands. The XL rotator makes easy work advancing the casing ahead of the excavation. A cutting shoe with drill teeth is attached to the bottom section of the casing. With 1,250,000 foot-pounds of torque, the rotator pushes the casing steadily down into the ground. The large-size grabs excavate the contaminated spoil. The spoils are placed in a lined dumpster before being removed for disposal. A 60-foot rebar cage is lifted and carefully placed in the hole by trained personnel. Concrete is placed in the hole by a pump truck. The casing sections are easily removed. The XL rotator has the capability to drill over 250 feet in depth using the fully cased method. It can also work continuously around the clock, going through contaminated materials. If you have any questions, please call Malcolm Drilling Company's corporate headquarters in San Francisco, California.